Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel where we talk about everything I want to, science and math. And today we're going to talk about error analysis. So, my class here is getting out their lab they did. And this is our estimating metric worksheet. And your first column was your estimate. Your second column was what it really was. The third column is the difference. Now, what about if it's negative? If it's negative, don't write the negative. Everybody good with that? Let's see if I can get something here to write on. All right, so let me show you this. I'm going to do it here for the video audience. Okay, so if I have this number, -3, these bars are absolute value bars. That's not 1 minus 31. It's an absolute value, okay? So that means you just don't write down the negative. There's two ways to think of this. The first way I like to think of it is it's like a little box that takes off negatives. I like to think of it like the movie Sky High. So if you haven't seen it, it's on Disney Plus. You should go watch it, maybe for the reference. But Sky High is about superpower teenagers, and one of them is Will Stronghold. He doesn't have any superpowers, but he goes to school anyway because he had superpowered parents, and he ends up in a fight and he gets his powers. So he's fighting War and Peace, and War and Peace is throwing fireballs, and Will Stronghold is throwing everything else because he's strong, and they go to ISS. And then ISS, it neutralizes all your powers, so they don't have any powers at all. But the principal comes in, it's Cummins Away, who was Wonder Woman when I was a kid, so I liked that part. And she said, your powers don't work in here. So it's sort of like a little box that take away your powers, it takes away the -3. So the absolute value of -3 is 3. Now, that's one way to think of it, and it's very useful when you're first thinking about absolute value. But there's a more correct way to think of it, and it's the number line. Okay, remember the number line from math class? So what, do y'all remember what 0 is called? It's the origin. Have you heard that before? The 0 is called the origin. So that's the origin. 1, 2, 3, -1, -2, -3. Okay, so one way to think about this is it's a little box that takes away negatives. The more correct way is how far is it to the origin? So if I start off at 3, it's 1, 2, 3 hops to the origin. Does that make sense? And if I start at -3, it's 1, 2, 3 hops to the origin. Either way, whether it's the absolute value of 3 or the absolute value of -3, the answer is 3 because that's how far it is to the origin. How do we feel about that? So one reason why it works is because distances are always positive. I don't say that it's 2 miles from my house to the library, but -2 miles from the library to my house, do I? They're both 2 miles. Now, there is a physics curriculum. It's this book right here, that Merrill or Glencoe Physics. And it's the physics book that the physics classes here at East are based on. You're not going to get a book, but the teachers are going to teach it this way. No. Yes, absolutely. So anyway, they're going to teach you that this one book that teaches the distances can be negative, and this is how it teaches it. It'll say you go 5 meters to the back of the room, and then you come back -5 meters, and 5 minus 5 is 0, so you're back to a 0 point. Does that make sense? So this is what I want you to take away from that. You can just sort of forget it till next year. But there are certain physics books that teach distances are never negative. But the one you're going to learn from next year, you're going to be taught that distances can be negative. It's just a different way of looking at the same thing. So then when you get to college, it could be either way. It could be distances are negative, or it could be they're not. Are we okay with that? This deeper little math concept? Okay, that's it. Okay, now get out your little piece of paper for the Metric Olympics. And we're going to talk about that. Yes? Yes. If you don't have your calculator, get it. You're going to need it. Okay, everybody got out your little half piece of paper? Okay, the first thing, you need the right answers to the graduated cylinders. So these are the right answers, small, medium, and large. Go put that in your calculator, and look, they can see it on YouTube too. YouTube, it's right over there. Look, I'll point to it. Whoop, whoop. More film with sound effects. Okay, so write those down. Now, for your third column, you do the same thing you did with the other one, and you subtract your estimate from the actual one, except when it comes to the graduated cylinders. How you're going to do the graduated cylinders is you're going to add up my 3 answers and get an answer. You're going to add up your 3 answers and get an answer, then you're going to subtract them, and that's the difference. Y'all need me to say that again? You're going to add up my 3 answers and get a number. You're going to add up your 3 numbers and get a number. You're going to subtract those 2 numbers, and that's your difference. And that's what it actually says on the little piece of paper, too. You see that now? All right. So that's how you get that third column. Next, what I want you to do once you get that third column is add them all up. Do you see the little box that says total? Look at the bottom of the third column. See that little box that says total? Add up all of your differences and write it in that box. Does that make sense? Do I need to get my paper and show you what it is? Y'all seem to be doing it. Add up everything in your third column and write the answer in the total. Because you only have positive numbers there, because it's absolute values. The differences are absolute value differences. Add them all up and get your answer and write it in that box. Were y'all good for the sub on Friday? For the teachers in here? Y'all weren't giving them attitude, breaking out in fights, smoking.
Oh, we're sucking so much. Some people were doing crack in that. I don't know what they're talking about.
I've been watching Breaking Bad, so.
I've been watching before.
Y'all shouldn't watch it. It's too adult. But as a chemist, it's very funny. It has lots of chemistry jokes. I'm just dying, and my family's like, "What? What? What was that?" Explain the joke to us. Okay, did y'all add it up? You got that total? Add it up. Okay, y'all got it? You added up that column. It shouldn't take you this long to add up one column in numbers. Put them all in, hit plus between every one, hit enter. Okay. Who got a total of your error all added together, not your error, your differences all added together of less than 100? Anybody get 100 or less? Anybody else get less than 100? The other class I had like 4 in each class. All right, you get a fabulous prize. Normally you have to make an A on the test to get a fabulous prize, but Chris, come get a prize. You don't take the Reese's if you're allergic to peanut butter. We got dinosaurs. We have some Jolly Rancher. We've got all kinds of fun stuff. You may have one prize. Anything in there. You took the Jolly Rancher.
I can eat it? Sure.
Enjoy your fabulous prize.
What is this?
I don't know. Some of the prizes have been in the basket all summer and they turned off the air. It might have got a little hot. All right. Okay, now let's talk about the last thing. And this is why I'm taping. is I'm going to teach you how to do the error, the last column. Okay, so it's a formula, and it's over here on the board. I'm going to write it on the smart board too, so that people in YouTube land can see it. Okay, the normal formula for error in chemistry, it is the accepted minus the experimental, I'm just going to say EXP, the absolute value divided by the accepted, I'm going to say ACC, times 100. And that is how you calculate error. It's percent error. But that doesn't work with ours because we don't have experimental and accepted. What we have is your estimate and then what it really was. You have estimate and actual. So this is our formula we're going to use. The actual minus the estimate divided by the actual times the 100. And this is the absolute value of it. Yes,
She's
Luke.
not listed on 100, but she doesn't want to see it. She don't want to do it.
Well, you, huh?
I didn't know how to do it at first.
Yeah, well, still, you get a fabulous prize. Did you have less than 100 too?
I got 80 for so that's
Well, I might give y'all a little prize at the end. Let's go on right here. So this is what I want you to do for your formula instead, how you're going to do it. I'm going to write it on here for our YouTubers. Okay, so what you're going to do instead is you're going to do the actual thing you measured. No. Yeah. Accepted minus experimental. Minus your estimate over the actual absolute values times 100%. Now that percent is a unit. You do not touch the percent button in your calculator. Slap your hand if it tries to touch percent. It will get the wrong answer. It's just a unit. It's like grams. So when you get the answer, you put a percent sign there. Does that make sense? So everybody try to get that last column. That's how you do it. And you will do this from now on in chemistry. When I was in college, if your error was too much, you'd have to redo you'd fail the lab. You'd have to redo it or you'd fail. So a lot of times colleges will set that you have to be within 10% or 5%. And if you're not, too bad for you. I don't do that. I just want you to be able to calculate it. Now, could your error be more than 100? Yes. Your error could be thousands of percents. They're not going to be negative, though. They'll all be positive. Does that make sense? All right. Well, that's our video. Now we're just going to go over problems. So remember, science is great.